here at the beginning, like I said, at the beginning, we're just focusing on discrete differences or not discrete gifts, basically average differences for whatever characteristics you have versus you don't have. I did have, remember I told you there might have been a mistake in my original slides. Let me just, this right here, actually I had to rebuild it. Oh, sorry, I haven't rebuilt it yet, but this should be beta 2. I'll adjust it in my slides, and then when I do that, I'll upload it again and just overwrite the one that's in there. Okay? So sorry about that. I just had a thing in the wrong area. Okay, so but basically with any type of just binary variable by itself, what we're going to see is just basically a parallel shift up or down given how large and the sign is on a particular, the variable that has the categorical variable. If I had additional ones, if I had like multiple categories, you would see multiple lines here that allow me to see various differences relative to the reference category. Okay, but like I said before, the likelihood that this is the same across every level of education is unlikely. Okay, and that's the key that we sort of start to look at in terms of econometrics is, you know, we want those differences, but at the same time, we want to know varied differences. Why, you know, pushing a little bit harder after matric and getting that undergrad helps out, and how is it helping out across the characteristics that you have? That is sort of just trying to push a little bit further and trying to discern exactly what's causing heterogeneity across individuals or across whatever we're trying to analyze there. That is sort of one of the major points that we're trying to find in econometric models is basically we try to find some type of outcome, but at the same time, we want to know why we're finding a varied outcome from somebody that has already done similar research, because we've added some type of a new factor to that outcome. And heterogeneity is one of those things that usually starts to help us figure out why we're seeing the varied outcome across the populations. Okay. Yeah. Okay, so if we were to actually take this and actually look at the actual coefficients, again, we could do, like I said before, wage and log wage. Now, each time I've done this, I've actually thrown out any of those zeros just to, because they're not exactly comparable, but at least if I'm running regressions, I should be comparing the same samples. I shouldn't have one that includes individuals. So in all these examples, I've already kind of restricted myself to only the positive wage earners in this case. Okay, but here, what's happening is, again, it's about interpretation. So if we compare these two models, it's basically two different outcomes, because one is in terms of wage and one is in terms of log wage. Again, like I said before, it's going to affect the interpretation of the beta 2 in terms of this is for females, because it's a semi-elasticity, it is roughly a 36%, no, I'm sorry, exponential, yeah, roughly should be, after you exponentiate, it should be like 32% decrease, difference in wages between males and females. In terms of wages by itself, we're talking about just, if I remember that this is in dollars, basically they're earning $2.27 less than in relative to males. Okay, so the point is that, again, it's all about the interpretation, but I'm restricting the sample, and at the same time, these should be in some ways comparable, but one is in terms of the log wages and one is in terms of wages themselves. Okay, but in both, we should see that difference as being negative, the actual magnitude, percentage or whatever might be just a little bit vary between the two models. But again, we shouldn't be comparing those results exactly directly either. Okay, so this is what we mean by when we're looking at those categorical variables. Now, if our outcome, or this is our primary variable that we're caring about, but this is just meant to be a control, again, how much emphasis we put on this depends on what your research question's about. So just going through the interpretation again. So without additional controls, basically what we're seeing is education, or comparing men to women with similar education outcomes in the level model. They're earning about $2.27 less than their counterparts at every education level. And then in terms of percentage terms across each of the education levels, they're earning 30% less. Okay. We could then go through the inference part. I don't put a lot of information in the slides about this, just because typically you do know how to do a t-stat. But if you do need to do it, again, this was done in R, and it'll do the calculation for you. Or as most people, when they look at their results and the tables, they look for those stars, and then they are happy. They really don't do the calculation sometimes. But at least with this, it's significant at the 5% level because it's definitely greater than 2. Okay. Could we add additional controls to reduce the wage gap? So in this case, let's focus on just the log wage, so we have one model here. In this case, we're seeing for education, we're seeing a effect of about 7% on each level of, or each additional grade level that you complete. Question is whether this is high or low is, dependent on a lot of things, but also how many things can we observe that should be determining the wages, but we've left out the model, which when we leave them out of the model, we basically end up in that error term. Okay. So in this case, if we added more and more controls, would we actually find that this effect rises or falls basically because we've done a better job at controlling or making sure that whatever effect we're getting is hopefully, the way I put it earlier was basically isolating that effect of X on Y. Those additional controls are helping us isolate a little bit closer what the effect of education is on wages. Sorry, this is... You see presentation? There it is. Is that it? Yeah. Okay. Okay, so in that case, that's the overall outcome. So basically, the thing is we don't know ahead of time. And actually, Woodruff kind of points this out. Basically, notes that basically the negative shift on female wages could be due to omitted factors. So that's one of the things that when we omit something that we know we should be including, but for some reason we leave it out, whether it's unobserved or just because we don't take the time, those outcomes that we're actually seeing are in a context that this is the model that we think is the best. But if it's not actually true, then basically we can find that they might shift it, increase or decrease depending on what's going on with the rest of the model. Okay? And I can tell you that basically, given all the research that they've been doing on this particular data set was from Mraz 1987. And they've been doing this for a long time, trying to improve just a little bit that estimate. In general, though, it still falls within some range of 5 to 10%. Okay, so And that's what a lot of research is basically just tweaking those models, the data in terms of maybe better or just a slightly different quality to improve our understanding of how you being here is actually improving your wages. You know, even though it's not technically a full classroom in that sense, it is in terms trying to improve on your education in terms of the econometric model. So it's important research, but at the same time, we're never going to be 100% sure that that's the most accurate answer. We're always improving on as much as either strategies or data. When we have two or more categories, you're going to start to see that we need a few additional variables in there. So remember what I said, if you have more than two categories, so in this case, say 3, we need 3 minus 1 new binary variables to represent those categorical variables. So think about when we're thinking about looking at your wages. One of the big things that come up a lot of times, especially with older individuals, is basically their marital status. Now, why would marital status actually affect your wages? Not talking about killing your spouse and going to jail because of what I said, but
I believe if you stay with your spouse, like you have a joint, you might have like joint account that separate. Let's say you single, you are able to pay for yourself. Say like you have an irresponsible person in your life, that's then a chance to have a very bad
you might want to reword that, but sure. So I think y'all are going off I'm thinking about it a little different. So most people, when they think about marriage or anything like that, they think about stability. So in some ways, they see it more as a stable outcome for them. But is that always the case across all genders? Probably not. So why would that factor be different across male and female?
I think it's because men are providers.
Again, I would rephrase it in a different way, but another way to see it is, okay, so if you know that in some of the dynamic shifts that we've had in society recently have changed this, but when we were looking at it prior, we were always thinking about it in terms of, if I know that once you marry, one of the next steps is children. So in some ways, they know for one point in your life going forward that basically you're going to be out for 9 months. So in that case, they might be kind of factoring in some things. That's one argument. There's other ones that basically once you have children, your priorities might change, which then lead to, taking into account that you might not be working as hard as possible. So that actually might lower your overall wage increase over years. In terms of men who are recently divorced, they could see that as being unstable in a sense that, there's going to be a lot of problems in the future in terms of, not problems, I'm trying to think about okay, I'm just going to stop on that. That'll be okay. So the point is that there's a line of arguments that you could make for this, and somebody could go across in a different way and make a whole line of different arguments. But the point is that these are things we should take into account of. We could also think about in terms of surveys. We have ways of classifying your answers to. Now I'm thinking about surveys being as the independent variable here. Sometimes we think about the surveys as being on the dependent variable side. But for now, I'm just thinking about on the right side that basically we would have two categories. And the first one, if we were doing some type of comparison, if we're thinking about it, maybe we should put as single being the base category and capturing all the rest, or however you want to argue. But in the survey, you could think about a different way that you might want to know how the agree and disagree are related to the neutral. So then you would have a dummy or binary variable for disagree, a binary variable for agree, and then your relative to the neutral. Or vice versa, you could look at disagree relative to the others. as having a neutral binary and a aggrieved binary. But the point is that the overall results should not really change. It's just changing how you discuss them. Okay, that's the key. Is whatever reference category you're going to talk about or create relative to the others, everything changes in the discussion. The relative impacts isn't going to really change as much because it's still going to be mathematically, if you were thinking about the binary, if I did male and female, if I switched it to where I was looking at male and the reference category became female, what happens is the sign is changed, but not the effects. You'll actually find the same standard error as well. What's happening is it's just changing the reference point. Now, the numbers change with these because you're changing the ref points and you have multiple categories to compare, but the general overview shouldn't change. Okay, so you usually want to change or create the reference relative to how you want to speak about it. And then with education, I've already sort of mentioned what you could do in terms of a breakdown there. Like, should I really be breaking up first and second, or should I just group them together in terms of everything less than metric? You know, there's some things that we can do in terms of this making different number groups. And that does clarify a few things sometimes. But just always keep in mind, however many groups you have, n minus 1. Okay? In terms of, and always, like I said, make sure that you discuss it relative to that base reference category. And that's why it'll help to always make sure that when you're doing it, it kind of works with the motivation you're making for your entire research question. You know, if you're talking about people that are widowed or, you know, in your research, basically that might be a good place to make it the reference category for your side, because you want to know how everybody else is doing relative to your chosen way of you've done your question. Okay, so making it divorced, and then it would mean that your whole discussion kind of changes. So I'm not saying it's right or wrong to do that way. Just make sure that it flows well with how you're going through your research. Now, in terms of an example for marital status, basically using it as a determinant on wages, we could basically set it up to where we focus on creating an if-else outcome for male. So basically, if male, 0, if female, 1. Or sorry, no, sorry. I'm creating a male binary variable. In this case, for if female was 0, now this male one's going to be 1, otherwise 0. So I'm basically just flipping it. I could have also just subtracted -1 from it and then multiplied it by -1. And that would have flipped it around to where it'd be male. And then I can basically go about trying to create some type of categories that look at interacting male and married, female and married, and then single. And basically I'm just flipping around from the married binary variable, and then creating a single female. What does this mean? So when I run this model, I have my education, experience squared. You see I'm starting to add more and more categories to try to make it a little bit better outcome. Then I have married male, married female, single female. So who's my reference? Who's my reference category in that? Single male. And I could have changed this to where I was focused on single female, married female, married male. It was just the last in the the one I chose on this. So just make sure everybody understands. So this is, even though I am doing some interactions here, we're not really going to be referring to them as interactions yet. One, because they're all binary, so it's not really what we think about in terms of an interaction for these cases, but we can basically make them categorical for marital status. So yeah, so I'm basically just going through the same model, but just adding more outcomes to it. In terms of what we see in terms of education, again, we're right around that 0.8, so about 8% increase. And then what we're finding is, okay, so this is sort of, we'll call this restricted regression, where we didn't actually classify or take care or control for your marital status. And then we have one that controls for marital status. Okay? And when we do this, we have to kind of remove female because it'll be collinear in this case if we didn't. But what we see is for married males relative to single males, they earn about a little over 21% more than single males. When it comes to married females, they earn about 20% less than single males. And this data is from the 70s, so keep that in mind. And then we have single females who earn about 11% less than single males. Okay? Now, from that standpoint, we sort of can do a comparison across these relative to the single males. But in the case of this is basically giving us an idea that we could then break this down even further. We could actually go for marital status, children's status. We could do a lot of things in here to get that variation that we're looking for. But the point is just making sure that you stay very particular on how you're discussing it. This is sort of the start to see that basically there are ways to bring out information that allows us to get away from that parallel outcomes. What it's saying is we're starting to look for differences across groups. If you want to call it heterogeneity at this point, that's good, because that's sort of what we're always looking for in terms of why certain portions of the population are, it seems in this case, to be have a different outcome in terms of their wages. Okay? Right now, like I said, it is a level difference, so it's not exactly, I wouldn't really throw it into the heterogeneity side yet, because that heterogeneity is still relative to, it's just doing basically a parallel shift. Okay, so it's not exactly heterogeneity across the other variables yet. Okay, but we can sort of start to get into that by looking at, if we were just looking at the wages, and I only took off the law just to keep it all kind of simple in terms of the derivative, we're looking at that education outcome as being constant. And constant for effect across everyone for each of their experiences is highly unlikely. Why is that? Basically, you get the most growth in your wages usually at the beginning of your tenure at a business. If you want to call it ageism, as you keep going through, basically your wages are still growing, but your growth in those wages is probably starting to cap in some ways, starting to just the growth is a little bit less each year. Okay, so in that case, we don't expect these effects to be always the same across every level experience. The first day you start versus the last day or the last year you start or in the business. It's unlikely that those are going to be exactly the same growth all the time. Okay, so if we allow other covariates to vary using some type of interaction, we can get a lot better, or not always better, but more complicated outcome. So if I actually start to interact, say, hold on, I forgot to do the interaction. Oh no, sorry, I'm using experience squared here. So if I was to look at it as looking at a square term, so from my standpoint, I don't think experience, my growth of wages in the first year is going to be the same as the second year, same as the third year. If I add a squared term to this, basically I can start to look for that nonlinearity. If I take the derivative with respect to it, I get the beta 2, and there should be a squared term here. It's just I was doing by the variable name, be 2 times beta 4 times experience. What that's telling me is this is no longer constant. It depends on the year that I actually am in my experience. Okay? And then if it's depending on the sign, that can tell you whether you're going to basically peak or if it's going to go on as a, exponential or if it's going to continue to drop. With most people, we think about in terms of experience, it's going to be a positive outcome towards wages. The more experience, you're going to gain in wages, but there's going to be curvature to it. The second derivative is going to be negative. So basically, you're going to get to a peak point. Okay, so if that's in terms of squaring terms, that's a way to actually look for those nonlinearities in that. Okay, if we're looking at in terms of interactions with other variables, we can actually then start to look at experience, but we can then see, okay, my experience with respect to, or my derivatives, the derivative of its wages with respect to experience is going to be beta 2 plus beta 4, and now I've interacted the two. No more square term, just interacting. So it's going to be beta 4 times female. This is going to give me the difference for experience for males and females. This would be for males. This plus this would be for females. So we're starting to see that we can actually get differential effects across variables in terms of this, and then also across different outcomes in terms of experience. It might have been better if I actually took the derivative with respect to females on this, and I would have got beta 3 plus beta 4 times experience. That would tell me how the effect for females is, how it's changing across the experience. Okay? So these are all ways of looking at it and trying to find that basically, I don't think, the year you finish matric is this, how much your wage is going to be is always going to be the same growth versus where you are now. Okay, so we're starting to see that the population outcomes might be different across varied characteristics that you have. Okay. So if I was to do this and I was actually to, again, just trying to make a simple one, education, female, and then interacting education with female, then we can start to see that characteristics across female. So basically, if I look at beta naught, that's for men's, that's the intercept. For beta 1, so what's happening here, the way you're kind of reading it, so if I'm looking at men, that's 0, that's 0. Basically, if you multiply things by 0, you're going to get 0. That means that if I'm looking at the intercept for men, I'm basically looking at beta naught. If I'm looking at the effect for men's education, I'm looking at beta 1. When I actually want to look at females, I'm looking at the females intercept is beta 2, which is basically, in some ways, we probably should say, it's sort of the intercept difference, really, which is beta naught plus beta 2. So I'm just saying that remember, it's that relative difference that we care about. That's why I usually don't like to talk about the intercept as much. But if we're looking at the female slope, it's going to be education, beta 1, plus beta 3 is the female slope. But if we did the derivative with respect to that, you see that education would still be in the model. So we're seeing the varied outcomes across education for that particular characteristic. We could actually test whether, beta 3, if we tested whether it's equal to 0 using a t-test, we could basically see, are there gender differences in the returns to education? So that might be telling. That tells us whether should we sort of be controlling for gender characteristics in this model. Because remember, everything that we add to this, we're actually adding, it can help us isolate the effect. But if it's information that's not really telling to us, really we should just be running education, and that's it. Because we're not really finding varied differences by allowing for the female, trying to differentiate between males and females. If we want to test for is the test that the wage is different for each gender, then we'd actually need to test both beta 2 and beta 3. So just looking at beta 3, we're looking at is there gender differences across education. The beta 2 and beta 3 equal to 0 with an F-test is basically saying, should we actually be caring or trying to model gender differences in this equation? So they're telling us two bits of information that we can then test. And then, so in this case, we could actually test a little bit further and see whether, because a lot of times when we run these models, remember, it's not about, well, I'm not sure if I said this before, but sometimes we'll run models and there'll be several variables within the model that are insignificant. It does not mean they're not playing their part in determining or helping out in isolating the effects. If we really want to do that, we need to do a test, a joint test that allows us to test whether the addition of multiple variables within the model, even though they're insignificant, are actually beneficial or not. So really, if we're going to do that, before we would need to change these into two subsamples and do something like akin to a Chow test. Basically testing the two sum of squared residuals, seeing if there's enough information or reduction in the amount of things going into this SSR to help us in terms of, even though they're not significant, but they might be jointly giving us enough information to help us isolate the effects. So there's a few packages that you can use. And when I mean few, I mean a lot. I mean a whole lot. The problem with doing these, each of these packages have a particular reason for being created. But to really understand what they're trying to do, the only way you can do that is to understand the interactions where you didn't use the package, that you are able to understand using the code. Then, once you know that my answer is matching their answer, then you can use the package, because then you understand how to use it. So yeah, so I do mention that there's one interactions package I've seen some students use. There's a few other ones that are out there. But like I said, however, to use these effectively, you should have a basic understanding of how interactions work. This becomes even more important when you go to nonlinear models. There's a package called marginal effects. Every student starts using that. Every student uses it wrong because they don't understand the actual interactions before going to something that's supposed to make your life easier. It will if you understand it from the beginning. If you don't and just type in a bunch of things you saw on YouTube and then it gives you an answer, that might not be the right answer. Get the basics down, then use the simplifications, because you can see that package or whatever package you're using is helping your life. It should match at least one of the answer that you found. Then you know you're doing it right. You have the right options chosen. You're entering everything in properly, and then you can use it for bigger problems. Okay, so just make sure you understand it before just using it. If you do that, if you go the opposite way, usually you can get in a lot of trouble in terms of trying to explain your results, or somebody notices that's not right because you chose one of the options that's, for one type of model versus, another option for another type of model. So just kind of get used to it first before jumping into a package that's supposed to do what you think it's supposed to do. So in terms of interactions here, I've rerun the model before, but I've only included the education and female interaction. So in this case, if I was to actually look at this, I would actually need to run a test in this case because that interaction is insignificant. And in this case, female by itself is insignificant as well. Okay, so that could be just from the controls that I chose, or it could be telling me more, but I would need to actually test, like I was talking about before, the joint test. A beta, I guess in this case, beta 2 and beta 6 is jointly equal to 0. Okay. We can also go a little bit further and actually interact it not just with one, but let's interact it with everything. Just go nuts. Interact it with everything. In this case, this is a little bit more telling. This is actually going to be telling us whether we should be jointly creating one model that, you know, doesn't really separate across gender, or we should be in some ways trying to control for that, as well as any type of interactions across the variables. In this case, I mean, it can tell us a little bit more about the female experience squared, tenure, but in some ways we can go about this, and I think I do have a chow test on the next page. Or again, we could just not even care about gender in this case. So that's right. Sorry, it feels like some of these are offline. No, that's right. So it's tenure, and then I just interact with education and experience. So you can do this in several different ways. But each time I did this, this is asking a very different question. So just throwing interactions can help you with those nonlinearities, but remember that it's fundamentally changing how we're structuring the question that we're asking. One is, you know, is there an educational difference across males and females and towards how it affects their wages? Here, is there basically a fundamental difference across all the things that we use for controls? Not just education, but there's a very difference across experience. You know, as I go up in terms of experience squared, and tenure. That's a bigger question. One is just about, you know, there's a very difference in education. One is about the fundamental work environment. Is there a difference? And then the last is not caring about gender at all, but you're sort of more focused on, does education experience, is there a connection? Is there an interaction that actually affects your overall wages? So these are, every time you do an interaction, you are changing that question you're asking. You have to be clear that this setup is what the question you're looking for. Not just, you know, it's fun to throw a bunch of interaction there because it improves my R squared or something else. Okay, you have to make sure that it's not going to fundamentally change what you're trying to, what you're fundamentally looking at. Because that last one, once I took out gender and I just focus on that outcome, you can see that my wage or my education actually did take a bit of a jump there. It's closer to 12% now. Okay. So these are where we're looking at those interactions and how we sort of interpret them. And you'll notice that I would have to actually go about, if I actually ask you, what is the effect of being female on my wages? It's not about just this. It's actually this, hold on, and that one. Because when you take the derivative, it is that coefficient on female and the coefficient on education female here. Then the level of education is going to vary across all that. Okay, so it's not about just looking at that interaction anymore. You have to see every place female shows up. If I take the derivative with respect to experience, education here, I have to look at every place education shows up. So not one variable, but wherever it shows up. Sometimes, even though something's not significant, we can actually, you know, take the lower confidence bound and the higher and show that 0 isn't a part of that interval. That would tell us with some, you know, some confidence that basically we know it's negative, we know it's positive. Or let me rephrase that, I shouldn't say no. We have some evidence that it is at least negative or is at least positive. And I know in some fields that I think it's labor and a few international fields basically do speak about that. If they can confidently say, you know, with some probability that it is not 0, we can at least sign it sometimes.
Would it be necessary to to note the adjusted R square? Because I see it's below 60%. And
I've been happy with 5% before. Your field sometimes does depend on, how it is, but there is I would say some fields do focus on this a lot, and I mean a lot. But really, this is only one part of the overall analysis you need. Like I said, magnitude, sign, those are just as telling as any adjusted R squared. Okay. And like I said, in some of the development fields, when this reaches 5, there's a party, pizza party all the way across. Just because you're explaining, say the time before when somebody did the research, they only were able to do 3%. You beat them, you're explaining 2 more percent than they did. And that's the problem with a lot of cross-section. You don't get that high R squared because there's a lot of variation that we can't see, and but it's still better than 0. It has some explanatory power. That's why I usually tell people not to focus so much on the R squared and focus on some of the signs and magnitudes that they make economic sense. That might be a little bit more telling.
And the statistical significance.
Again, that's field, but yes, most time people focus on that. But yeah, so but remember, everything that you're doing here in terms of the inference, the effect, the magnitude when you're talking about the economic size, all that is going and trying to explain the outcome you get, and they all work together to, build confidence in what you worked on. There's no one statistic you can focus on here and say, that says that I'm right. It's not that way. It's a combination of all of them. Even when we talk about endogeneity later on, a lot of people focus so much on all the little tests that you have, right? But a lot of times when actually readers are going through it, they're looking at your intuition, because all those tests are fine, but at the same time, they're only trying to support your argument. They're never going to say this is 100% correct. And there's always a case, and it has happened, where you've done research, somebody does it 5 years down the road, and the thing that happened that they got, the result they got was just a fluke because it worked at that time. You changed the timing of where the instrument was created and stuff like that. It destroys it. So that's why a lot of the stuff that we build on those areas is all built on intuition. Your arguments and how you define it help build confidence in how the reader is taking it. The tester, they're good too, but at the same time, that confidence built is in that argument you're making and how you can show that your argument is likely correct.
So if your results are, I wouldn't say spurious, but like for a lack of a better word, like they don't back your argument, could you state your case by incorporating like economic theory?
Oh no, you have to. With these the models I'm talking about more on the instrumental variable world, so you have to go for the theory side. I am one of those people that kind of get away from GMM type models and things because people will throw them in there to claim exogeneity, but there's no theory kind of backing it up. So then it's basically you run a model, it works, but the theory would help on that. It helps you know what you expect out in terms of sign, that magnitude. So that's where the theory can really help in those areas as well. That's sort of what I mean. Sometimes there's cases where you don't have the theory, but you can build intuition behind how other theory has sort of shown certain outcomes that might apply. That's what that whole field is about. But I'm trying to make sure that people look at more things than just the R squared or those stars. Because your whole model is supposed to be modeling the way you want to answer your question or the way you want to analyze your question. It's not just one variable or whatever. It's the combination of everything. So just make sure that you keep that in, that you're not over focused on one thing versus all the rest of it. But yeah, sorry, I'm not sure if I answered your question, but yes, that's my key for doing this. Basically, focus on a lot on everything as a whole, not as just bits and pieces that you like. Like I said, it's each field is almost like a little own social group in a sense. So they have their methods, they have their way of doing things, and whenever you're talking about some other social group, they'll go after them on something. So that's what I'm trying to say. That's even why whenever we're creating our papers and we're sending off to journals, we see where our research is going. That's why we send it to those places, because those people, know why we're doing this. I've had ones that we sent off to other areas. So I've talked about the LPM model versus the Logit model. We send it to a journal and basically say, why aren't you using the Logit? The LPM is, stupid. But the thing is that there are reasons why you do that, because of it's sometimes about simplicity, but it's also about in those cases we want to control for some unobserved effects. In LPM models, they work better than in Logit models. There's some of the conditions that work a little bit better, and if we only care about the average outcome, then basically they're usually, unless there's really bad properties within that data, usually going to give similar results. That's why it's very, what do you call it? Social group is basically there's things that in your field you do, but in other fields they would say you need to check this, this, this. So I would stick to what your research area is sort of doing and what they concentrate on as to make your argument. That might be the best way of doing it. Okay. Yeah, it's very subdivided. And like people get on to me in international trade or while we're using gravity equations that, I don't look for stationarity because it's not what we really do in that particular field, given just the way everything is set up. If somebody said it was wrong and it was coming from the AER or, econometric or something like that, then they're most likely wrong. That's what I'm saying. The quality of your referencing is another tell, because I've seen reviewers basically go in, not even reading the abstract. They go directly to your references and go flipping through. They don't see any quality journals in there. It's probably not going to go well for you. That it's not saying that it's not. Sometimes that might be a bad way of doing it, but the problem is that your arguments are always going to be built upon that research you're citing. So the better the quality of that research, or the journals are coming out of, the names are coming out of, and it sounds strange that you're having to do it that way, but it does help, especially making the arguments, especially if you're using a method that hasn't been used before. Because they would have to, just going out and saying it's wrong, that would probably mean that you didn't want to publish there anyway. When you're trying to do something new that's not used by a lot, you have to make sure that you have the proper amount of support, that support is of a higher quality, and it's all about that. Your research isn't just about a new method. It's not about a new data. It's encompassing a lot of stuff. So what I'm trying to say is to focus on the whole, as a whole, not as just these little pieces. What I'm doing is I'm taking that first column here as a simplification. So the only thing we did was add in the education interaction. But from that, I can basically get some good information. Now, it's no longer parallel. We see that females basically across education, those predicted wages were lower. But then when we hit 7th grade, I guess. By the way, these are, because I'm confining the covariates as well. This is going to change, so it's most likely this is just a guess. Okay, but the fact is that we see that these two things cross, and at one time we actually do start to see higher on females. That it's no longer the case that it's always that outcome. But if I add a new variable, if I add new basically new variables to this could shift a lot. But the point is that it's good to know that whatever model we're actually looking at, that we're taking as a truth for whatever question that we're looking at, that we can start to see variation. And then we can start to kind of figure out why we're seeing this. Maybe it's because we're basically the ratio to males to females is actually lowering in most university classes now. More females are going to university. And for my honors and masters, basically men are outnumbered in those classes. It could be that. It could be that men or that families are waiting longer to have children. Or there could be new laws coming in that help take away from that discrimination that just because I'm going to have a child, you can't basically keep my wages lower than somebody of the same education just because they're male. It could be a lot of different things. But the thing is that if that was your main story, maybe this would start to be more telling, and that might be a way of, explaining your question, research, whatever. That's probably the focus of my last 10 years, 5 to 10 years of research is basically just looking for reasons for that heterogeneity. Okay, so sometimes it's telling to know the difference. It's good that we know that there's differences, but at the same time, let's start figuring out a little bit more clarity on why those differences exist. Then, if you want to get more fancy with it, I only put this here so that you can try it out if you want. But I will tell you that your computer might just say no and shut down, because it does take a little bit of work. But you can get a little bit more detailed in terms of, let's look at my predicted wages, but let's look at differences across education, experience. And we can look at it in both sets. I chose a bad angle for this, but if I was able to actually move it in this direction, if I had changed the angle a little bit, you would see there's more curvature in terms of the male, and it's relatively flatter for the females. You would also see that it's higher in terms, well, not very much. I think it was just a little bit. But I could have done this a little bit more fancy, adding numbers and stuff like that. But the point is that I can start to look at it. It's not just about education females. It's also when you start interacting a bunch of things, there's no longer just a set here. We're actually trying to look at it in multiple dimensions. And that's just adding another layer to something you can talk about. Okay? And, like I said, you can try this. You might just want to try one on your computer first, depending on how old it is. If I remember right, I'm using Plotly, which, it takes up a little more RAM than usual. But yeah, just keep that in mind. These are different ways of looking at the same question again. Okay? Even though it's a simple regression that people have used before, if you're looking at in terms of class, most people would stop at this. But some people are visual, and visual aids in your research do help out in terms of explaining your way of reasoning or your arguments. So these are just other techniques to basically push your ideas a little bit further. Okay. Then again, like I said, we can start to focus on differences across group. This is where we're looking at the chow. Now there's a regression-based version of this that you can see in Wooldridge sometimes, that basically we start to look at an F-test across all the particular interactions to see if we should really be having just, one equation versus one that actually differentiates across genders. Or we could look at it as two separate regressions. In most cases, these should be almost equivalent in terms of what the response comes out. It's just basically preference on how you like to do it. I prefer the single equation method just because it's just straightforward for me. And the other one, you have to actually run two different equations, one for female, one for male. But you can see that if we were actually to do an F-joint test or the traditional Chow test, in general, even though they're not exactly the same in terms of the outcome, in terms of the F-test, they both reject the null in this case, that basically it's meaningless to define groups. Basically, there are differences across male and female in this case. Okay, so these are all ways of trying to figure out whatever characteristic, whatever you're trying to get at that might be helpful with this binary variable or binary categories that you're using. These are all ways of trying to motivate it, and then also trying to push your argument that basically this is a new aspect that allows for that heterogeneity to be explained. Okay? Let me see if I want to do that. Yeah, okay. So there is one other thing that I put in here, but I don't go into it a lot. So one thing that you might have heard of in the past, or what we're trying to deal with, is non-random treatment. We're going to go a little bit more into this on Thursday, but just using categorical variables, there is a way to sort of pull out, or remember that if we don't control for it or attempt to control for it, whatever we're looking for ends up in the error term. That's usually bad for us if it's also correlated with other things on the right-hand side variable. But if we can kind of figure out what might be causing that selection, or certain characteristics, certain reasons why we might see selection in that case, we can actually try to control for it. We can make an attempt. And in some ways, even making an attempt is better than ignoring. So just to give you an example, if we were thinking about a binary indicator as a treatment, so basically there's some variable W that, a treatment is applied versus 0 where there's no treatment. Give some examples in terms of grants on first come, first served basis. So basically, who's the most likely to be first in those lines? You could say unemployed, if depending on what it's about. I probably should say that. If it's some type of policy, for a program to help you find a job or anything like that, unemployed are usually the first to show up in that. It doesn't mean that no employed people will show up there, but if they're working, the unemployment, they have more time, so it might show up first. You also have conditions in terms of more time on your hands. There's a lot of different ways to say it. It's a lot of mean ways to say it as well, so I'm trying to be careful. But basically, you can kind of guess who's going to be the earliest in particular in terms of a first come, first served basis. Early applicants receive the grants. If it is just you show up first, you get the grants. We can think about targeted policies that go towards particular specific groups due to observable characteristics. If we're thinking about low-income individuals, if this is some type of targeted group, we could think about how that's not exactly random. We've already specified that it's a targeted group. So there's going to be some information there that sort of determines who they are. Then we have decisions by others. Think about school administrators or policymakers decide on who qualifies. You got the parent beating down your door because you haven't let their kid in. They might be one of the people getting in next, just because we call it the eager parent scenario. If you want to read about that, it's kind of funny whenever you read it on a blog and they talk about the economics and stuff behind it. I don't think it's gotten as bad here yet, but I know in some, I think Japan and South Korea is pretty bad. The U.S. is getting worse. So the problem that we have is trying to mimic a random assignment. We're going to kind of go, like I said, go more into that on Thursday, trying to make adjustments, because one of the biggest problems that we have is observational data is rarely random. It's unlikely to be random. So we have to have we have a little bit of a challenge there. So in this case, we can think about the challenge of treatment is not randomly assigned, which we require for an unbiased outcome. Individuals self-select or are selected based on a certain criteria. Now, this is where binary variables can actually be a little bit helpful in terms of controlling for it. It's not perfect. Nothing we ever do is really perfect on this, but we can maybe mitigate some of the problems. So what if we can control for these confounding variables? So approach, condition on the additional covariates or confounders that affect both the treatment and the outcome. So in this way, we're conditioning maybe if we can figure out whether something is related to low-income outcomes for individuals. Think about, just knowing whether they're employed or not. Family background. These are things that if we can condition on, we're more likely to pick up whatever's causing that selection. It's not saying that that's going to be a perfect outcome, but the more we can pick out information that helps with that selection, it's a control. We're pulling it out of the error term, that selection problem, which then allows us to hopefully mitigate any type of bias. And the assumption is once we condition on these covariates, the treatment of the assignment is assumed to be independent of the potential outcome. So basically what it's trying to say is if we can pull it out of the error term and condition and estimate it specifically, it's less likely to be a problem in terms of information in the error term that's correlated with the right-hand side variables. This is still a big assumption no matter what we're doing, but if we're doing a decent job, we're at least maybe mitigating the problem, okay? And that's a lot of times what we're trying to do. We're just trying to reduce the problem, most likely, mitigate it, however you want to say it, but basically we're just trying to shrink it as much as possible. So this is sort of with the non-random assignment or independent variable side. Let me just see something real quick. Yeah. So because I didn't make, because we kind of speak about this on Wednesday, I think, I didn't put a lot on the slides of the dependent side of it. I just wanted to keep it simple and straightforward so we can actually compare to other types of models that are very similar. So instead of focusing on the independent variable side, we can actually think about the binary being on the left-hand side. In that case, it does change our interpretation of the expected outcome. We're no longer worried about the level versus log sort of thing, percentages versus that level outcome. We're thinking more that it actually changes how we interpret this. This becomes the expectation of a binary variable given the covariates on the right-hand side end up being a probability. And because when we write this out, we actually can get rid of the effect of being the expectation with respect to 0 or the y equal to 0, we can focus on just the probability of success, that you actually have that particular outcome. If we do that, then basically we end up with something that we can see as being an interpretation is the coefficient is given the characteristic is true, or sorry, in this case, the expected outcome in terms of education, as education increases from by 1, what is the change in the probability of whatever my dependent variable is? In this case, we're using labor force participation. So if I go from grade 1 to grade 2, this is the effect of the probability of being employed. Okay, it just changes that interpretation a little bit. But again, it has some disadvantages because again, in the LPM world, we're thinking about probabilities being linear. We don't think it's probability being linear. So when we do that, going from grade 1 to grade 2 is the same as getting going from master's to PhD. We don't really think it's going to be the same level of the change in the probability. But again, it doesn't mean that it's wrong at the average. So I just wanted to point this out. And the disadvantages we have in this is that whenever we actually predict the probabilities across the sample, we can end up with levels that are above or less than 1. That are above 1 or less than 0, which we know probabilities have to be between 0 and 1. So that is an issue. And also the marginal effects, the probabilities in this case are linear, which I've already sort of pointed out that doesn't make a lot of sense. We're comparing really two ends of the distribution. The two tails, we don't think those effects are going to be the same. And then we have a problem with heteroscedastic errors we're going to talk about a little bit later. But because we know exactly what the form looks like, we can make adjustments for that. Okay? The advantages, the reason why I want to point this out, is because it's easy and fast. OLS, using a dependent variable as 0, 1, is quite quick to estimate, especially for very large models. When it comes to, when we move into logit and probits, we have to go into the maximum likelihood estimation world. Those become a little bit more difficult. Their interpretation a little bit more difficult as well. So we also have trouble when it comes to fixed effects, which we'll discuss a little bit. So in that case, it does have that advantage of being easy, fast, and for most time, when we think about unobserved heterogeneity, fixed effects parameter, we actually benefit by the fact that we can use it in the OLS world versus an MLE world. And at the means, like I said before, basically we get similar results. As long as the data's not, some people like to say not well behaved, but basically it's just not, I call it not strange. Usually you should get the average partial effect or the average marginal effect should almost be exactly the same. You shouldn't get a huge gap in terms of the probabilities. Okay? So I'm just trying to point out that, there's a lot of people going against this, but in the development world, they're actually using it more because it works for the types of models that they're using because they want a quick average effect. And they want to control for a lot of unobserved outcomes. So that makes a little bit easier to use. And then we'll get why it's a little bit harder to do logit and probit in the next lecture. Okay, so that is categorical variables, both independent and dependent. So, of course, I set up a practical. Hopefully this one's a little bit better worded. But what I'm going to ask you to do is basically I want you to use, so I'm also doing this for another reason. You notice that I haven't shown you a lot of code or anything like that. This is the time where you're going to use some of the stuff that you learned yesterday along with some of the references that allow you to look up how to do certain functions and other things to complete this. I want to make sure that you're not just going from the code that I have, that you're actually looking around to get ideas on how to do these things. So I'm going to throw in hints in this case. And in this case, we're going to be using a data set GPA3 from the Wooldridge package. If you don't remember how to grab it, those are from yesterday's notes. And we're also going to use the link just if you need more information about the variables, the data set itself and everything. And then we're going to load it, and we're going to use an LM command. Now, you know how to find information on the LM, which is just standard OLS. And then I just want you to sort of interpret that beta 2. We're also going to estimate this more advanced model that allows for interactions on several of the variables. And then we want to test whether there's differences between males and females. Do they follow the same model? Should we even be caring that there's differences, or should we just be estimating one model and not caring about gender? And then we want to create a binary indicator from season, which is in the data set, and estimate an LPM model. This is where you put what you've already got, where you practiced, and what we've done to use as a way of getting a little bit more familiar with R. Okay? Thing is that we are so close to lunch, it's about 5 minutes from now, that we'll kind of take this into after lunch as well. So after lunch, we'll spend about, let's say, 20 minutes or so, 20, 30 minutes, and then we'll kind of go over it and then continue on. Okay. So that's the way we're going to kind of set up today's few little exercises. Basically, we're going to kind of go through things and then we're going to practice them as we go.